In this segment, we're going to take an example from quadratic spline interpolation. We'll be using the quadratic spline theory which we have learned to be able to solve this particular simple example. So here is the example which you can read now. We are given y versus x data. However, this particular data is incomplete. We are not given the value of y at x equal to 4. We are not given the value of y equal to 6. Then we are told that hey, there are certain quadratic splines which are going through consecutive data points right here. And again, some of the spline information, interpolate information is not given to us. Finally, we're asked to find out what the value of c is, which is one of the constants in the third spline interpolant, the one which goes through 4 and 6. Now, if I was going to find out what c is, that means that somehow I have to figure out what this particular spline is. And that means that I have to maybe set up 3 equations, 3 unknowns for the value of b, c, and d. I'm not necessarily saying that, hey, we can solve it by using 3 equations, 3 unknowns. At least we know that in that particular spline we have 3 unknowns, b, c, and d. How can we figure out what c is out of those b, c, and d? Now, one of the things which I know that this particular spline, which is right here, it goes through x equal to 4, and it also goes through x equal to 6. Unfortunately, the values at x equal to 4, the values of y at x equal to 4, and the values of y at x equal to 6 are not given to us. But we also know that this particular spline, the second spline, does go through x equal to 4, and the last spline, the fourth spline, does go through x equal to 6. So we should be able to use that information to be able to at least figure out that, hey, this third spline, bx squared plus cx plus d, which goes through points from 4 to, which goes through points x equal to 4 and x equal to 6, what the value at x equal to 4 and x equal to 6 is. So if you look at the spline, second spline is f of x is equal to 2x squared minus 2x squared plus 14x minus 9. The value of the function at x equal to 4, which is one of the endpoints of the spline, the minus 2 times 4 squared plus 14 times 4 minus 19, and that gives me equal to 15. Now what we're going to do, we're going to do the same thing with the fourth spline, which is right here, and we're going to see that, hey, what the value of the function is at x equal to 6. So we have f of x equal to 25x squared minus 303x plus 928, and this one is valid between 6 and 7. And if I want to find the value of the function at 6, which is one of the endpoints of the spline, it would be 25 times 6 squared minus 303 times 6 plus 928, and this number here turns out to be equal to 10. So what we have been able to do so far is as follows. We have been able to find that the value of the function at 4 is 15. We are able to find the value of the function at 6 is equal to 10. So what that means is that in this spline we can at least set up 2 equations. One which is telling you that the value of that spline is 15 at x equal to 4, and that the value of the spline at x equal to 6 is 10. So we'll have 2 equations, but we still have 2 equations but 3 unknowns because c is an unknown. So let's go and see that how can we set up this third equation here. Now, one of the things which we have learned in our quadratic spline interpolation theory is that the splines which have a common point, that the first derivative is the same. That is, that the slope of the function at the common point is the same if it is an interior data point. So this particular spline goes through x equal to 4, this particular spline goes through x equal to 4. So whatever is the slope of this function at x equal to 4 has to be same as the slope of this function at x equal to 4. So what does that mean? That means that, let's clear this up. That means that the derivative of minus 2x squared plus 14x minus 9 has to be equal to the derivative of bx squared plus cx plus d. That the slope of the second spline will be same as the slope of the third spline, but not at every point, but at the common point, which is x equal to 4 and x equal to 4. So what that gives me is as follows. It gives me minus 4x plus 14 at x equal to 4 will have to be equal to 2bx plus c at x equal to 4. That's after I've taken the derivative of one spline and the derivative of the third spline. But these two spline derivatives are only equal at x equal to 4. This gives me minus 2, and this gives me 2b times 4 plus c, and that gives me 8b plus c is equal to minus 2. So I have gotten that additional equation which I needed in order to be able to set up my three equations, three unknowns, to be able to find b, c, and d. Although I'm only interested in finding c, but I do have to go through the process of setting up these three equations, three unknowns, to find the value of c. So let's set up the other equation. The other equation is that at x equal to 4, the third spline, this particular spline, the value is equal to 15. So b times 4 squared plus c times 4 plus d is equal to 15, which gives me 16b plus 4c plus d is equal to 15. So that's my first equation. Then we already know that, also know that the value at x equals 6 of this third spline is 10. So bx squared plus cx plus d at x equal to 6 is equal to 10. So that gives me b times 6 squared plus c times 6 plus d is 10, and that gives me 36b plus 6c plus d is equal to 10. So that's my second equation. We already have calculated the third equation, which was 8b plus c is equal to minus 2 by equating the slopes at x equal to 4, and that's my third equation. So I have now three equations, three unknowns. So the first equation, which tells me that the value at x equal to 4 is 15, that I'll be able to set up in the matrix form as 16, 4, and 1. I got b, c, and d here will be 15. The second equation, which tells me that the value of the function at 6 of the spline at x equal to 6 is 10, that will give me 36, 6, and 1 is 10. So that's the one which is telling me that at x equals 6, the value of the spline is 10. And then I have this third equation, which is here, which will be 8 here, and 1 here, and since there is no 0 contribution, so it will be 0, and that will be minus 2. So now I have three equations, three unknowns. I should be able to use any of the methods which I have learned so far to be able to find out what the values of a, b, and c, b, c, and d are. So b turns out to be minus 0.25. C turns out to be 0, and D turns out to be 19. And since I'm looking for C, that's my answer. And that's the end of this segment.